having people slowly trickle in. Hello, hello. If you feel comfortable, please turn on your video so that we can see your beautiful faces. Please keep your mics off for now. But yeah, no, welcome to today's workshop, everyone. I'm super, super excited that you guys are all here today. As you all know, today's workshop is on leveraging serverless in full stack development with Eric Johnson from Amazon, specifically from the Amazon application, serverless applications at Amazon.
That's right. Yeah, good job. That was impressive.
Yeah, sorry about butchering that a little bit, but I try my best. Anyways, hello everyone. I'm so excited that you're here. Please in the chat, drop where you guys are from. I know this event is international, so it's always cool to see where everyone is tuning in from. Personally, I'm from Toronto, Canada, here in Maple Land. Hello, hello everyone. But yeah, no, please feel free to start dropping in where you're from. For anyone new coming in right now, please feel free to turn on your video so that we can actually see each other. And yeah, that is it for me, guys. I will be in the background. I will now give the floor to Eric.
All right. Thank you very much, Jennifer. I appreciate it. Yeah, I would encourage you to turn your video on as well. This is, I'm a pretty relaxed, easygoing, love to interact type person. If you see me staring over to the side, that's where all your faces are on my screens here. So yeah, I encourage you to turn your camera on if you can. I am coming to you live from northern Colorado, where it is cold and wet and dark outside. We were 80 degrees and sunny 2 days ago. So you just never know. They say in Colorado, if you don't like the weather, wait 15 minutes and it will change. So, all right. So the way I want to kind of do this, I am good with questions. I probably won't see the chat as well as I should here. I'll be watching. Oh, we have Salt Lake City. We have some Canada, Toronto. Oh, Canada's taking over. Nice. All righty. Well, I will tell you, part of our serverless team that builds some of the stuff I'm going to be talking about today is all based in Vancouver. So I love to get to go up to Vancouver and spend some time there. And so big fan of that. So. All right, so let's get started. Today we're going to be talking about leveraging serverless in full stack development. And really, I kind of also titled this The Case for Serverless. I'll tell you a little bit about who I am, just so you see why do I have the credibility to be up here talking. Again, my name is Eric Johnson. You can find me on Twitter at EDJGeek. I answer lots of serverless questions. You hear a lot about Dr. Pepper, you hear a lot about pizza, you hear a lot about drumming, all the things, but most of all, you'll hear about serverless and specifically AWS serverless. I am a husband and a father of 5. That's not a miscount. I have a ton of kids, and so we have a good time. I'm a printable developer, which apparently I just changed this right before when Jennifer and I were talking, and I misspelled that. So I am a principal developer advocate for serverless at AWS. If you watch me for any given amount of time, I will misspell something. I've always said, if I were a better speller, I'd be 3 times the developer. So a couple of rules when I'm talking. And rules is probably a little strong. A couple of guidelines that are going to help you. And so when you're watching, I make a lot of references to numbers, things like that. And the first rule or guideline is, this is any number I want it to be. I'm going to hold my hand up and I'm going to say 7 or 9 or 10 or 33. It never fails. I go into a restaurant, table for 7, and I'm alone at the bar. So whatever. But these are quotes, not apostrophes. I know that. I do this all the time. These are double quotes. It's a lot easier than this. And finally, these are thumbs. So I do make 1-finger jokes. I'm comfortable with that. If that makes you uncomfortable, I'm also comfortable with that. So I'm gonna have a good time either way you go. So just relax and have fun. So all right, so let's get started talking about serverless. And I hope to leave. Hey, Jennifer, can you tell me what is our time? We have an hour, right? Okay, I'll just make sure I didn't misunderstand that. So I'm going to leave time at the end for questions and answers. I'll also watch the chat. I'm okay to take a pause and talk, about some things. But so don't be afraid, or you can save them or ask me in there, and I'll try to glance periodically. All right, so let's talk about serverless, and specifically the application architecture journey. Now, whether you're brand new to developing, or you've been developing for a while, or you're an old pro, you've gone through some kind of application architecture journey. And the funny thing is we do this over and over. We kind of have new permutations of, architecture, things we like. And so as we grow as developers, our architectures grow. As new technology comes out, our architectures change, things like that. But I'm going to talk about kind of a basic one that I went through, and probably a lot of you have as well. And our whole world probably started with what we call the single server architecture. If you're building an app, most likely at some point you have built an application that was all hosted on a single server. For me, my mom's closet, or maybe a data center inside your office, something like that. But you had your proxy, your firewall, Nginx, Apache, whatever, Zeus, F5, you name it, it's probably out there. You have a server, maybe IIS, Apache, Tomcat. Your code and your database all lived on this server. And when that one server went down, the whole thing went down, right? And this is where a lot of application architectures start. But what happens is, as we grow and we say, you know what, that's a lot of energy, and that's a lot to be going on with one server, we need to kind of break that out. And I'm sorry, I move around a lot. So if I'm making you dizzy, I'll try to be still there. I'm used to being on a stage. It's this virtual thing still, even though I've been doing it for a year, it's still kind of new to me. So what we do is we realize, okay, you know what, we need to move to what we call a tiered architecture. And so we're going to move stuff. We're going to say, okay, our proxy and our firewall are going to live on one box. Our server is, our front end, back end, data, things like that are going to live on a server in the middle, and then a database is going to be pushed on the other. Okay, so you're still kind of in a position where one of these goes down, your application goes down, but we've spread the load a little bit so that our infrastructure can be a little healthier, because we're not taxing one machine, we're spreading it across multiple. And we may even get crazy. We say, we're going to separate our client and our back end into two separate architectures. All right. So this is great if all you're running is, a WordPress about your family, and if it goes down, you're not losing millions of dollars per minute, right? But when you start taking on clients as a developer, you start building out applications, you quickly realize that this doesn't work if I need that site to be up reliably. Because the truth of the matter is, and Werner Vogels, the CTO of Amazon, said, everything fails all the time. At Amazon, when we build, or at AWS, when we build architecture, we build it so that it doesn't go down, but we build it because it will. And I'll explain that. Is we try to make it as, testing, the hardware, everything's picked so that everything stays up, but we plan for things to go down. We know that something like an availability zone might go down. That's why we have multiple availability zones in a region. So if this one goes down, this one's still up. And if you've architected for that, your website's going to stay up. And so what we learn is you need redundancy. For a reliable site, your site needs redundancy. So with service, we start spreading things out. We have our proxy firewall, and actually you'd probably do that as a double system as well. So you'd probably have an active, passive, some type of setup for your proxy and your firewall. Then you'd have your load balancer, that would point to one of two machines for your client. Then you have your backend load balancer that'll point to one or two machines for your backend. And then you'll have a database that's replicating for, if one goes down, your data is replicated and you can point to that. Hopefully, if you've been developing for any amount of time, this looks familiar to you, right? And so as your applications scale, we build in this redundancy. So for a production application, that's not going to be two machines. That's probably going to look more like this, where you might have an active or some type of load balancer setup, your proxies. Then you're going to have a ton of machines handling your client. And you're going to have another set of load balancers. And you're going to have a ton of machines handling your backend, right? But the truth about this is, this is more redundant. Yes, it's more infrastructure to manage. Yes, more management, and it's more cost, right? So if you're running your own data center, and what you end up doing is you spin up all these boxes. And the reality of that is we don't just go grab a box and it's up in 5 minutes, right? When we manage our own infrastructure and things like that, especially in our own data centers, it means ordering the hardware, provisioning the hardware, patching it, getting it all built up. If I'm doing it for you, then I'll probably get it wrong the first several times, take it back down and bring it back up till you finally have hardware. So it's not a quick turnaround. This is something that we plan for and provision a long ways ahead, right? So you say, okay, hang on, Eric, hang on. There's this new thing we call containers. What about containers? Containers are a great technology. And I you know, for a lot of my development, I use local containers, things like that. And this is not going to be me dissing containers at all. I actually love containers. They're great technology, but they're still infrastructure intensive. You still manage the infrastructure, right? So if we look at that, when we build it out, let's go back for a second. Your container, probably you may have your client, your backend, your database all in the same cluster, different containers handling that. But the reality is you still have machines, right? You still have to spread that across different machines. You might break out your database separately. And so your client, your backend are different containers. Those may even be on separate containers themselves. I mean, there's all kinds of permutations of this. But the reality is you still need the hardware and the infrastructure, and you have to manage that to spread that out, right? So the truth here is it's still more redundant. That's good. More infrastructure. That's needed. More management. That's where it gets like, you know, there's a lot here, and more cost, right? So then you think, okay, so I get what you're saying. I'm not going to manage this in, you know, myself in my infrastructure, right? So, excuse me one second. I have my Diet Dr. Pepper that keeps me going here. So, and so you say, you know what, I'm going to go to the AWS cloud, and that's great. I work for AWS. We love it. You know, I was a solutions architect. I helped large companies. I worked for a partner company. I helped large companies move from on-premises or on-premise, I never remember which it is, to the cloud all the time, right? And it saves money. It saves management. There's a lot of things there. So let's look at what this would look like if we move to the cloud. So if we move to the cloud, then what we're doing is there's some really cool tools to help you kind of build out your infrastructure, right? It allows you to say, you know, instead of me managing 30 boxes one at a time, I can manage one box, put it in multiple availability zones, and have it scale as needed. We have this technology called auto scaling, right? So it's always going to scale. But the thing about that is, notice to be redundant and to be available, highly available, you always have to have at least 2 instances, right? You need to always say, if this one goes down, this one's going to be ready. And they generally need to live in separate availability zones, okay? This is this is the start of a reliable, redundant infrastructure, right? And so I do the same thing with my backend. And I'm going to use some of the cloud services like Amazon RDS, which has that redundancy and resiliency built into it as my database. And I'm going to get rid of managing my own load balancer. I'm going to move to an application load balancer. We have multiple types. And now that fleet of load balancers and scaling is going to be handled by Amazon. So there's a lot of things going on there, right? Well, what about containers? So what about containers? So that looks the same, right? We still have application load balancer. We're going to run maybe an ECS service, which is this managed container services and RDS. But the thing about this is moving to the cloud offers sophisticated automation and tooling to help manage scaling and redundancy. But, okay, there is this, I used to be a youth leader, and we called this the butt brush, right? So the butt brush meant everything comes after or before the word but, you kind of brush away because what's after is going to count, right? And the thing about this is there's still infrastructure to manage and pay for. You will always have infrastructure up and running to have a redundant, resilient website if you're running server full. And there's all kinds of different names, but things in serverless. I'm sorry, things that requires you to manage servers. So that's why I want to introduce you today to serverless itself. Now, let's just get this out of the way. I know in your head, you probably already know this, but you'd be surprised how many people ask me this. Yes. Serverless does run on servers, but the thing about it is not servers that you have to manage. All right. So let's like this. There's 4 kind of core ways we kind of describe serverless. And you hear people all over the world describe it as a lot of different ways, but let me kind of tell you how we look at it at AWS. Okay. First thing is serverless is you have no infrastructure provisioning, no management. You don't need to get up in the middle of the night and add more machines. when your site's getting loaded. You don't need to take care of dead machines or things that need to be patched and things like that. It's automatically done for you. Amazon handles that for you. AWS does. Excuse me. Automatic scaling. When we build the services, we already say, when your load gets heavy, we're going to scale up for that. Okay, we're gonna scale up to handle a lot of load, and that's understandable. What a lot of people don't realize is that when your load is not heavy, we're going to scale down as well to the point of 0. Okay, so very few services, and even with containers, different things like that, they don't scale to 0. Now, what that means is, I only pay for what I use. And that's the third thing we talk about. We pay for value. You'll never pay for a machine to sit there and run in a true serverless architecture, right? It will only be when something happens. We'll talk about that in just a minute. All right, and the last thing is it's highly available and secure. With serverless, we're going to manage your fleet of servers to handle it. We're going to manage, the patching, the security, the data centers, all that. All you're going to manage is your code. You're going to design your infrastructure. Hey, I need these parts of it, but you're going to manage the code part of that. All right, before we go on, I'm going to check, make sure we don't have any questions here. Yeah, there's no such thing as a stupid question. You're exactly right, Jennifer. I appreciate that. So, all right. So let's jump on. I'm not seeing any in here at all. So, all right. So the next thing we have, the next thing is, let's talk about what a serverless application is. Okay, so it's kind of funny. When I talk about serverless, if you've never, and I won't ask you to raise your hand in the room, but if you've never used serverless, I'm going to kind of give you the introductory elevator idea of what serverless is. Okay, here's the very technical definition. All right, buckle up. This is going to get technical. Serverless is something happens, we recognize it, and we do something. There you go. Write that down. That is the high-tech serverless explanation. Now, let me simplify that for you a little bit. The idea behind serverless is it is an event-driven model, right? There's not a port that you have to monitor. There's not things like that. It is an event-driven model. And events can be any number of things. Very common as API is an API call. So I'm getting an API call. API gateway will handle that and create an event. A change to data. A click of an IoT button, a light switch getting turned on. There's all kinds of things, all considered an event. And we have supported native events in AWS, and then you can create your own event through the IoT setup that we have, or through code sending out events. So there's all kinds of flexibility there. So when an event happens, then we do something. Now, a lot of times that's something with our Lambda function. Now, not always, but a lot of times that is, you've done something, so we need to run some business logic. We need to do something with that data. And so what happens is we invoke a Lambda function through the Lambda service. And a Lambda function can contain your code. That's it. You don't have to do anything else but your code. It can be Node, Python, Java, C#, Go, Ruby, or any language you want using our custom runtime API. Then what happens is that Lambda function does something. It's going to update some data in DynamoDB. It's going to turn on a light switch in another country or a light bulb. It's going to, again, it's kind of only limited by your imagination. So something happens, we recognize it, and we do something. And that's really kind of a simplified look at how serverless works. Now, serverless is used for a lot of common cases. And we say Lambda, and I probably ought to update this deck, because it used to be that serverless equaled Lambda, meaning you get an event and then you run code. But now a lot of times serverless means you can chain together services without ever writing code. I can connect API gateway to step functions, and don't worry if you don't know these, that's okay, but a step functions, and the step functions talk to different services without you writing a single piece of code or very little code, depending on what you're doing. Serverless is used for a lot of things you can see here. These are just some of them. These are certainly not the exhaustive list, but IT automation, chatbots, data processing, backends, web apps, so on and so forth. And most of what we're going to talk about today is web apps and backends, because I don't want to go, I could be here all day and we can talk about the scope of a lot of these. So, all right. So let's look at, we're going to go back to our stack. Okay, so we talked about building this stack. And I want to show you what that looks like in serverless, right? So we have this infrastructure that we built out, and we're saying, you know, we're going to move things to the serverless. Now, the assumption, this is our infrastructure that we built. The assumption is that your client is separate from your backend, meaning they're running on a separate bit of servers and backend. If they're not, don't sweat it. We'll cover that too, okay? But a lot of what's going on nowadays is this spa idea where it's a single page app where they're running that at the client and then they just talk to the backends for data. And that's kind of what this is talking about, but we'll talk about the other two, so don't worry about that. All right, so here's our application. So the first thing we're going to do is we're going to get rid of all these servers running our client and our load balancers running our client. Okay, and let me show you how. Okay, in our system, we have a thing called Amazon Simple Storage, right? If you've ever heard of it, it's also called S3. It's one of the most popular, one of the most well-known services we offer. And did you know that you can host a website directly in Amazon S3? And the fun thing about that is it'll host HTTP, HTTPS. You can put your custom domain on it, and it'll handle your object versioning if you want to run versions up there. You have bucket policies with security and control around there. And here's the number I want you to see. And you may have heard this before. We call it 11 nines, 99.99999. You know, and it sounds like I'm doing the Batman theme there. Data durability. What this means is we're already going to have multiple copies of that website for durability for you. You no longer have to run a ton of servers. It's going to automatically be there. When a web browser hits it, it's going to get pulled from the S3 as a service, and off you go. Now, we took that and made it a step better, and we wrapped it with a service called the AWS Amplify Console. If you're familiar with Amplify at all, it has several different components to it. This particular component is the Amplify Console. And what we did is we said, all right, we're going to let you host an S3. We're going to wrap it on front with CloudFront, which is our CDN, which is a content delivery network. So you can have it all over the world immediately cached, right? And we kind of handle that for you. And built in is you're going to get a CI/CD pipeline. So let me show you what that looks like. I would go to the Amplify console. If I have my front end client, all my spa inside of a GitHub repo or a code commit repo or several other type of repositories, I would then take Amplify console and I would point it at that. And I would say, monitor this repo. And every time I push a change, you update my website and publish that. So I get CI/CD right out of the bat, including I can write some tests in there. I can have staging. I can have feature branch, different launches. I can wrap a password around it so only I and my team can get to it. A lot of power there. I mean, literally just point and click and off you go. All right. So what we've done here is we've said, we're going to get rid of all these servers that I'm running for my front end. Now I'm not having to patch them, manage them, add or take away, even with my auto scaling. And now my client scales to 0. I only get billed for that front end on data transfer and storage charges in S3, and that's very minimal. It's going to cost you a lot less than running one or multiple servers or even one. All right, so here's what we're done now. Now that we've removed our client and we only have our back end, now we're going to point that proxy or firewall directly at my back end load balancers, right? So, or my routing. So now I'm just worried about back end. So we can get rid of those as well. We're going to use an API gateway. On AWS, it's called API Gateway, but it's an API Gateway service, right? And so this is going to handle your load balancing. It's going to handle your REST and WebSockets. It handles up to 10,000 requests per second. That's a soft limit. Okay, so you can raise that. It can provide regional or private or global options. SSL offloading, so you don't have to handle your SSL at your server, your load balancer anymore. It's handled right at API Gateway, and everything behind it is protected. You can also push your auth, your authorization out to API Gateway, meaning I no longer have to write that code into my application. I can use JWT authorization. I can use IAM authorization, which is our access and identity management. So there's simple OAuth. So lots of different options there. So now what I've done is I've been able to pull out my firewall, my proxy, my load balancers, everything. All I'm running at the moment is this backend service. So let's get rid of that. Okay, this is the next thing going to serverless. So we're going to get rid of that. So we talked a little bit about before, and I'm going to tell you, AWS Lambda is going to handle all your business logic. So what does this mean? So instead of me having 34 bazillion servers, okay, that's a technical word, 34 bazillion servers, instead, I'm going to have 1, 2, 3, 4, 5 Lambda functions, depending on yours. And I'm not going to launch, I'm not going to say, all right, I had 30 servers, I need 30 Lambdas to handle this. That's not how Lambda works. What you have is you put up a Lambda for each amount of code that you want to do. And you think about how you design stuff. When we design applications, we want to have, some good principles, keep it simple. We want to have single responsibility. We want to have isolated, decoupled, functions. And we'll talk a little bit more about that architecture in a little bit. But let's say I have a user functionality, I have a reporting functionality, and I have an order functionality. And my 30 servers are handling all that in one single app. Well, what I can do is I can say, I'm going to pull that reporting functionality into a single Lambda function, or a set of Lambda functions, or its own serverless application. I'm going to pull the user function out, I'm going to pull another one out. So now what happens is I've got these Lambda functions that are dealing with there's code for you only as needed. So they'll come up, they'll run the code, they'll go away, and you only pay for the invocation. And the fun thing about Lambda is you get the first 1 million invocations free per month, per account or per organization, right? So if you have a small startup, you can run, and I'm not kidding you can run your application for almost free. I'm not saying free, but almost free, because you're getting rid of all these servers and you're able to run just within a Lambda function. All right, so let's see here. Where are we at? Okay, so the next thing we're going to do, now we've gotten rid of everything except for our databases. Okay, excuse me 1 second. I'm sorry. I hate to do this, but I'm gonna step away for 1 second. So I think this cold weather is getting to me. So sorry about that. Okay, so we've gotten rid of everything except for our database, right? So now we want to get rid of our data, not get rid of it, but now we want to do something that's serverless or better for redundancy and resiliency in our database. And in Amazon, we have a lot of options for that. Okay, and so I'm just showing some of these here. Aurora, Amazon Aurora it can run RDS, SQL. It has we've built in huge amounts of redundancy and reliability into Amazon Aurora. How you doing? And so it can run SQL. It can run Postgres and MySQL. And what they've done is they've actually separated, they being AWS, we've separated the storage and the compute. And your storage is stored across 6 replicants. So you're going to have 6 copies of your data every time across 3 zones, and your storage is separated out. And we've even made a Amazon Aurora serverless that more machines will come in as needed. We have DocumentDB, which will allow you to do it is Mongo. It's Mongo compatible database. Amazon DynamoDB. I'm not going to go through all these. I just want to talk about the first 3. Amazon DynamoDB is my go-to. If you ever heard of a little thing, it's a little website to start up quite a few years ago. It's called Amazon.com, and they have a lot of orders that they handle, like on Black Friday, things like that. The magic behind it is Amazon DynamoDB. It's massive amounts of input and output, and you can do global tables with this. So very powerful. So generally, depending on if I'm going SQL, so I would use Amazon Aurora for my SQL stuff, or Amazon RDS, or if I'm going NoSQL, and then I would look at DynamoDB or DocumentDB. All right, and like I said, these are the ones we mainly look at with those. So our relational database, you can see here, I kind of talked about a little bit of relational database. We have serverless with the Amazon Aurora serverless, highly available, auto scaling. Amazon RDS, simple scaling, engine native replication. We also, we can do Oracle and MS SQL in RDS as well. and then DynamoDB and DocumentDB. All right, so I've thrown a lot of information at you in the last 30 minutes, okay? And it's like, whoa, okay, how do we keep up? But I want to show you, what does it look like when I put this together? What does a serverless application look like? Okay, I've decided, Eric, you've convinced me I want to do this. So let's do it. So taking our same application, this is really what a basic website would look like. And there's some choices here. So my users, I'm going to use Amazon Gateway on the front end, and Amazon Gateway is going to handle, well, let's actually jump here. I told you earlier, I would talk about if you're not doing a SPA, if you're rendering your HTML out of your service, a Lambda function can do that just like your services can. You can run an Express, or you can run there's all kinds of templating formats you can run where you can output actual HTML no problem, just like a normal server. So you can absolutely do that. So you're going to have your users going to hit Amazon API Gateway. Your business logic is going to be handled as a Lambda function. And then we're going to store our data either, or both. You can mix it on an Amazon DynamoDB table if it's NoSQL, or Amazon Aurora if it is SQL. And we built this really cool thing called Amazon RDS Proxy. Let me tell you why. If I'm doing serverless, remember I talked about a Lambda function comes up, it does its business, and it goes away, right? So it's very ephemeral. But that's problematic when you're dealing with SQL connections, right? When you're managing these SQL connections. And so there's, all right, is it still there? Did it go away? So we built this really cool service called Amazon RDS Proxy. And you could call, and it will actually maintain your SQL connections for you, and your Lambda function just checks with it for its connections. And you can isolate your security, your database password, things like that at the RDS proxy. And then your Lambda function just uses the identity and access management to get access to that. Now, let me say that simpler. You as an administrator can manage the credentials for a database at Amazon RDS Proxy where none of your developers will have access. And then you can give the developers access via the Lambda functions, whether they can read from it, write from it, do both, whatever. So lots of control there. So like I said, the pools and connections are shared there. So we build this all out. Let's talk about that resiliency for a minute. So with your resiliency, all of these services are going to scale as you need them to scale, right? So your Amazon API Gateway is going to handle up to 10,000 requests per second. Okay, Amazon Lambda function is going to handle up to 1,000 concurrent. Now, there's a difference there. I want you to understand the difference. One is per second. So let me explain that for a second on Amazon API Gateway. If I have 10,000 requests come in, and 5,000 of them hit in the first millisecond, it's going to handle all. I mean, that's concurrent. But if 5,001 hit in the first millisecond, that one is going to get rejected as too many. But if that one hits the next millisecond, it's going to be handled fine. You have a bucket of 10,000 requests across a second that API Gateway can handle. And remember, that's a soft limit, so I can blow that up if I need to. Most of the time, you don't need to if your application is architected well. A Lambda function can handle 1,000 invocations at the same time. Okay, so if your Lambda function can do its business and return in 10 milliseconds, depending on you. I mean, there's all kinds of factors there, right? What are you doing in it? You know, how much memory and storage have you given it, things like that. But if it can do that, then you can handle thousands upon thousands upon thousands of requests per second. So Amazon DynamoDB also is going to scale. Same with RDS Proxy and Amazon Aurora. So hopefully you're seeing here is instead of me managing all these services and servers, I'm just going to manage my code, right? And AWS Serverless is going to scale as I need it to scale. It's going to be patched. It's going to be managed. Security is going to be built in. Everything's going to be handled. All right. So let's talk about some of the other features if we do this. And I'm looking, lots of them. All right. So yeah, let me come back here really quick. I see a question. Is there a free tier to try these things out on AWS? There absolutely is, Zachary. Most of our services have a free tier that's a year long. However, with serverless, a lot of these are perpetual. The AWS Lambda free tier is perpetual. I run a website that I had for like, I think I pay $1.02 a month because of the storage I've got. I don't hit the invocations. So DynamoDB has a free tier. API Gateway has a free tier. Lambda Services has a free tier. So yes, you have a lot of those. All right. So let's take a look. Oh, good. And someone put the link in. Awesome. All right. So let's go ahead. So we've talked about the scalability and getting around all this management. But now let's talk about kind of offloading some stuff to make life easy. We already talked about AWS Amplified Console. It's the client application hosted serverlessly and scales to meet load because it's sitting on top of that S3. The next thing you can add is Cognito. Amazon Cognito is a service that can authenticate and manage your users for you. You are also free to use like an Auth0 or something like that. What I do encourage you to do is don't write your own authentication mechanism. There's a lot of good ones out there, some really good standard ones, and it's not something you don't want to take on. So you let a Cognito handle it for you and use standard OAuth and JWT tokens, or you can use IAM, which is extremely secure. So user management and authentication of Cognito, and then AWS API Gateway interacts with Cognito or an OAuth 0, something or Auth 0, excuse me, to authorize your user. And you can actually do that at a route level. You can say they got to be part of this audience and have this scope before they can come on this route. So you have a lot of control there. All right, so let's talk. I said I would talk about architecture for a little bit. We have, again, orders, users, and reports, right? And these are the different things. So what I can do is I can have one Lambda function that handles orders. And really, probably what I'll do is have more like a set of Lambda functions that do an application. I can have one that handles users and I have one that handles reports. And so if someone hits the endpoint, my domain /reports, then this Lambda function on the bottom is going to get invoked. If someone hits the orders, it's going to get invoked. Someone hits users and passes a user ID, then this middle one's going to get invoked. And it's going to scale as you need independently of the other Lambda functions. So if I'm getting slammed for reports, my Lambda functions are going to do that without affecting the users or the orders. And that's a different story if you're running them all in the same application, right? So we've decoupled these applications, right? And they're all dumping and talking to DynamoDB as needed. Now, here's the fun part of this. Sometimes we don't need to make a customer wait. One of the things we have to be aware of when we're building applications is the longer a customer watches a wheel turn, the more broken your website is to them. I mean, we live in an age where if it doesn't work right away, boom, I'm out of there, I'm gone. So we want to get an answer back to the customer as fast as we can. This is where you start thinking asynchronously, meaning what's the minimal amount of interaction I can have with the customer before I've got enough information that I can do some work later. Okay. And so one of the patterns for that, we can build that right into serverless. And this is just one example. So don't get overwhelmed with this, just kind of give you an idea. But let's say I have a user that makes an order, right? And he makes an order, and that order, I process that order, I drop it in DynamoDB, and I get back to the user and say, hey, your order has been requested. Okay. Then what happens is DynamoDB has a thing called a stream that comes out the backside that I can invoke another Lambda function. And I can say, oh, we got a new order. I want to do several things to it. So I'm going to put an event on an event bridge bus, meaning I'm going to throw this event out there and then I'm done with my work. That event, based on some rules, will trigger 3 separate Lambda functions. One notifies our warehouse. The other notifies accounting. The other, they do different things, right? And all this is done asynchronously and then can write back to that DynamoDB database. And then the next time the user logs in, whatever, your order is processed or your order is shipped or whatever. So there's a lot of function or flexibility that you can have when you're building serverless applications. All right, so a lot there. It looks like we've got some questions coming in. Excellent. All right, so tangents, okay. All right, this is a bit of a tangent, so feel free to hold this question to the end. But I'm curious to get your take on a recent announcement, especially because you announced it, about the work being done to integrate. I don't know what you're talking about. Yes, I will actually. I'm going into this a little bit and I'll talk about that. Do you think this is going to be a trend towards greater integration between the two to create a unified CLI tool, or is this going to be more of a one-off? Okay, so excellent question. A little bit of context real quick. And actually, let me go through this section real quick here to give some context. So when you're getting started, right? So this section is getting started. What do I do? How do I do it? You can always go to the console and build. You can log into AWS console. You can create a Lambda. You can create an API gateway. You connect it, and that works great for learning. But when you have to build something that you're iterating against all the time, and you need to deploy to several availability zones, that's not the most efficient way of doing it. And we highly recommend that you start with a framework. And a framework is built to help you create, develop, and deploy serverless applications. It can be used from your desktop. It can also be utilized within a CI/CD pipeline. The one I generally talk about is SAM, which is the serverless application model. And I do not have a slide in here for CDK, and that is not because I'm sliding CDK. It's because most times I tell people when they're starting with serverless, start with SAM because it's probably going to be the easiest approach. However, CDK is super powerful. Let me talk about that in a moment here. So SAM comes in two parts, right? This often freaks people out. I've cut the squirrel in half. There were no squirrels harmed in this presentation. So the two parts are one, the SAM templates are what we call the model. And this is where you have the shorthand syntax to express resources. This is infrastructure as code. So I create a YAML or JSON. I saw someone saying it was all YAML. You can do JSON as well, but you'll be a better person if you use YAML. That's just my opinion, just throwing that out there. But it allows you to actually model the architecture that you want and then deploy it. The second part of this is what's called the SAM CLI, right? And the SAM CLI is a tool that provides local development and debugging for building, packaging, and deployment, right? So this is the local CLI that interfaces with the transform. And this is what I believe it was Anthony was asking about. Okay, so Anthony, to answer your question, no, this is not just a one-off. This is just the beginning. I will throw that to you. Our hope is that the SAM CLI is, whether you're using SAM, the SAM model, or you're using CDK, a SAM CLI provides you with a fully interactive local development environment, right? And so it will work with either. And continue. We want to both the SAM CDK team and I just said it, SAM CDK. Woo! The AWS CDK team and the AWS SAM team want to meet developers right where they're at, regardless of the framework they're using. And right now, CDK and SAM are the ones we support, but we want to help developers, right? And so we're going to continue working on this. We're going to continue iterating on this to build it out further. And what this allows you to do, it used to be you could only use SAM templates to use the CLI. It would read the SAM templates. Then you could invoke a Lambda locally. You could invoke it via an API gateway. If you were building in CDK, then you had to do what's called synthesize or output a SAM template. Then you had to do a few hops to be able to use that inside of SAM. Now, both of these frameworks end up going to CloudFormation, which is Amazon's full-on infrastructure as code service. So it allows you to describe all these. So what we did is we said, no longer are you going to have to export that out of CDK. You're going to we'll just read CDK projects natively and allow you to locally invoke a Lambda function, locally invoke via an API gateway. Now, real quick, if you're not familiar with CDK in general, this probably should have been the beginning, is CloudFormation will outlive us all, that's right. CDK allows you to use actual program. Now, there's a big debate, is YAML a programming language, is JSON programming language? We're not going to get into that. But those are the languages used with SAM. With CDK, you can use TypeScript, Python, Java, and there's others coming out. And so I can actually use the programmatic power of TypeScript to build my infrastructure. So I can loop and create Lambda functions on the fly. So there's a lot of power between the two of them. So hopefully, Anthony, that answered your question. Great to hear. I think each of these frameworks have different things to offer. Yes, I absolutely agree. All right, so I've done a lot of talking. One thing I would point you to before we jump into questions and answers is I would point you to serverlessne.com. This is a website maintained by the developer advocate team at AWS. We add all our blogs, all our talks, all our everything to this session. So I really encourage you, or to this website, I encourage you to check it out. A lot of answers to if you're building serverless, there's learning paths, there's just a lot here. And with that, I'm gonna actually turn it back over to y'all, and I'm gonna answer any of the questions that I can. Again, my name is Eric Johnson. I highly encourage you to follow me at EDJ Geek on Twitter. Glad to answer. If I don't know the answer, a lot of times I know the people who do. A lot of times I don't know the answer, but I can find the people. All right, with that, I'm going to exit out of the PowerPoint and I'm going to bring up Zoom straight up, and let's see if I can answer some questions.
I'm kind of curious how you think stuff like Pulumi and Terraform kind of fit in, the stuff that they're trying to be infrastructure as code, but that's kind of cloud agnostic.
Yeah. So I think they're great products. We partner with both of them, Terraform, Pulumi. I think they're great products. The cloud agnostic adds a measure of complexity to what they're building, and man, I praise them for it, because it's a tool that's needed. I come from a background. I was a systems architect at a partner company, and we worked with all the major clouds, and being able to kind of move between them was very helpful. So and you ask how I think of them, I love them. How do we interact with them? As best we can. We want them to be able to use our services. We want them to be able to build serverless for it. So yeah, that's going forward. We want to be able to interact with them as well, and that's all.
So the idea that you would want them to also like compile down to CloudFormation. It seems like everything like compiles down to who's ever like infra as code thing is kind of at the base layer. So if you then can build a language that then just abstracts everyone's individual infra as code language, then that's like it's interesting computer problem.
Yeah, it is. You're right, and it's that. So CloudFormation is this. So there's three ways to deploy something on AWS. There's the CLI. Okay, so that's the AWS CLI, and that's one-off. I'm deploying one thing at a time. There is the API, which is what Terraform uses. If you're in, or it's been a while since I used Terraform, but when you use Terraform, they interact with the API and launch stuff, and they maintain their own templates. And then there's CloudFormation, and CloudFormation is kind of the central all things, if I'm building applications. So it really makes sense for things to finally end up at CloudFormation if we can. When they don't, then it makes it a little harder for us to interact with them, but not impossible, and it's something we're looking at.
Talk more about the AWS API thing. I don't think I've ever heard about that, like just using the APIs.
Yeah. So you can using the SDK. I can actually pull the SDK like for JavaScript for Node, and I can actually create a DynamoDB table using the API. I can call it create table. I can create an EC2 instance. Call it, rather than doing it through a CloudFormation. CloudFormation, I think at the end ends up calling all the APIs as well. So it's this weird abstract.
So you're saying CloudFormation is not the base layer, the API calls it the base layer.
So don't hold me to that. But I'm pretty sure that's the case, and I'm probably going to get called into HR at the end of this meeting. So that's all right. Don't worry about it.
That'd be a cool demo though, because I always see it's usually like you're deploying to some sort of infra as code. It's very rare I see someone actually build something with just like, hey, the API, but it makes sense like conceptually why you could do that.
That becomes very handy when you need to dynamically generate references based on what customers are doing. And so we have clients that in their code itself are spinning up a table or spinning up another Lambda function or something to that effect. Because you don't want to do that through CloudFormation or CLI.
Yeah.
So what other questions? Someone loves Pulumi. Yep. Pulumi's they're doing some cool stuff over there. All right. I'm not seeing any other questions come in. Jennifer, you have any questions?
No, I'm good. You did an amazing job, everyone.
Thank you.
If you have any more questions for Eric, if they come up afterwards, I already dropped his Twitter there, so you can ping him, DM him if you like. But no, honestly, thank you so much, Eric, for your time today. We appreciate your energy, your enthusiasm, and the awesome knowledge that you dropped on us. So thank you.
Thank you very much. Yeah. All right. Well, y'all, thank you. And please reach out. Glad to help. And have a great week. It's Monday, folks.
Yeah. Thank you, everyone. Have a great week. Bye-bye.
Bye, all.
Bye, y'all.